This is a lesson on solving systems of equations by graphing. With solving systems of equations, you're going to be given two equations, each with two variables, like x and y, and we're going to find a solution that is one or more solutions that's a solution to both of those equations. We start this when we're learning this by being given two equations and then being given something that might be a solution and testing whether that is a solution. So in this one we're given two equations here, y is equal to x plus 1, and the other one 2x plus y is equal to 4, and we're asked whether the ordered pair 1, 2 is a solution. In other words, will the ordered pair x is equal to 1 and y is equal to 2 fit? So this, of course, is x and this is y, and so we're going to plug that in. So y is 2, x is 1, and we get 2 is equal to 1 plus 1, question mark. 2 is equal to 2, so it is a solution to that equation. Now we have to test whether it's a solution to the other equation. So here we have 2, we said x is 1 plus y, and y is 2, and we're going to test whether that's equal to 4. And so we have 2 plus 2 is equal to 4, and 4 is equal to 4. So yes, this is a solution. Okay? If we tried something else, so let's say I try is 0, 3 a solution? Well, I go in here and I go 3 is equal to 0 plus 1. Well, it's not even a solution to one of them. I don't know about the other one, but I can stop there. So that's the first part. We test to see if it's a solution. And it's a solution if it satisfies both equations. Now, we're going to be given things like we're going to be given two equations. So here's an equation. I have x plus 2y is equal to 7. And this was an equation in the book. And then they give me another equation, x is equal to y plus 4. We're going to graph these two and sort of see what it means to be a solution. So to graph these, let's put them in slope-intercept form is one of the ways we learned. So on this one, I'm going to subtract x from both sides. I get 2y is equal to the opposite of x plus 7. I'm going to divide each side by 2. And I get y is equal, well, this is the opposite of x over 2, but that's the same as negative 1/2 x. And then plus 7 over 2. And I'm going to put that as a mixed number, that y-intercept now, so that we can graph it easier. So here I get this is equal to plus 3 1/2. 7/2 is 3 1/2. This one should be a little easier to solve. I'm going to subtract 4 from both sides, and then basically I'm done. I got y is equal to x minus 4. So there's one equation in slope-intercept form. There's the other, and that also gives me a little room to put a graph in here. So now what I'm going to do is very carefully graph these. We're going to find, through this unit, we're going to get many different ways to find the solution. With graphing, you have to be very precise to do this. But the first one I'm going to graph is this y is equal to negative 1/2 x plus 3 1/2. So my intervals here will just be 1 apiece here. So 1, 2, 3 1/2 is about there. And so that's my y-intercept, and my slope is negative 1/2. So I go down 1 over 2. That's pretty close, so I'm also going to do something that's equivalent to 1/2. I'm going to go down 2 over 4. So that's about there. And so that should be good. And I'm going to draw a line all the way through that. And so I'm going to do that very carefully. And matter of fact, I'm standing up to do this. So very, very, very carefully, I'm going to draw that. And let me see here. Okay, so I'm going to draw it right through there. And so that is the line here, y is equal to 1/2 x plus 3.5. Now, I'm going to do this other one. It is, the y-intercept is -4, so down 1, 2, 3, 4. And then the slope is just 1. So I can go up 1 over 1, or up 2 over 2, or up 3 over 3. I want to get those, but it's going to be all the way along this diagonal right here. And now I'm going to draw this. And this here is the line y is equal to x plus 4. Now, it's really important that we examine a little bit of what these mean. This equation of this line here, every point along this line, an infinite number of points, satisfies this equation. So there's a point here that looks like 1, 2, 3, 4, 5, 6, 7, 7, 0 satisfies it. We know that 0, 3.5 satisfies it. But any point along here satisfies that equation. Likewise, any point along this line, an infinite number of points, satisfies this equation of y is equal to x plus 4. Okay, so this point satisfies it, this point, every point in between those points, this point down here, an infinite number of points satisfy that. The question is, how many points do these two lines have in common that would satisfy both equations? And the only point that satisfies both equations is that one right there. And that point is 1, 2, 3, 4, 5, 1. So the point 5, 1. So we say 5, 1 is a solution to this equation here and this equation here. Let's check it out. We'll go back to the original equations when we didn't have them in slope-intercept form. And we go, we have x plus 2y is equal to 7. So I'm saying 5 plus 2 times 1 is equal to 7. And so that's 5 plus 2 on this side, and 5 plus 2 is 7. Well, on this side we have 7s. And so this is true. So it satisfies that one. Let's see if it satisfies this one to double check. So we go x is equal to y plus 4. We get x, again, we were saying is 5. So 5 is equal to y is 1 plus 4. Again, this is from the solution we found here. And then we get 5 is equal to 5. And yes, that does check. So by doing this, seeing where the two lines cross and seeing what solution they have in common, tells us that 5, 1 is the only solution to those two equations. Now, we're going to do another one quickly. I'm just going to make one up. Let's say I have, I'll put them in slope-intercept form. I have y is equal to 5, let's make it a little slower, 2x plus 3. And then I have y is equal to 2x plus -1. So now I'm going to graph those. So I'm going to go ahead and graph those. And I'm going to graph these two. Okay, sort of a big graph there for that, but that's okay. So y-intercept of 1, 2, 3, and slope of 2 up 2 over 1. Well, we know that these two have the same slope, right? If they have the same slope, we know that they're parallel, right? Well, if they're parallel, the question is, and this one's slope of 2 up 2 over 1, if they're parallel, we know that they never cross. Well, that's a pretty bad drawing of a parallel line there, but trust me, these two should be parallel. Sorry, they're not quite parallel, but we're going to say they're parallel. Oh, that's because I didn't draw this one right, did I? It's, let's see, 3, and then up 2 over 1. Oh, up 2 over 1, up 2 over 1. We're a little off, but it's okay. But these two are parallel, theoretically, and if they're parallel, they're never going to cross. If they never cross, they never have any solution in common. So with parallel lines, lines with the same slope, we know that there is no solution. Okay, one more thing. We're going to now get one that has a, I'm going to draw another coordinate plane here. And here. And that's x and that's y. And I'm going to give you two equations here. How about y is equal to 2x plus 1. And then also, I'm going to give you 2y is equal to 4x plus 2. And actually this one we'll just graph here. So it's 2 is the y-intercept, up 2 over 1 is the slope. And so I'm going to draw that. 2 over 1, okay, is the slope. So I'm going to draw that. Now let's put the other one. The other one, let's put it in, I'm going to subtract 2y. I'm going to put it in standard form. And so I get 0 is equal to 4x minus 2y. And then I'm going to plus 2. And then I'm going to subtract 2. And basically I get 4x minus 2y is equal to negative 2. Well, this is in standard form, so let's put it in, let's use the opposite of a over b for the slope. And a would be 4, and b is negative 2. So we know the slope is equal to 2. And the y-intercept, I'll call it b, is c over b. And so that's going to equal to that's going to equal, let's see, where do we have it in standard form? That's going to equal to negative 2 over negative 2, or that's going to equal to 1. So we have a y-intercept of 1 and a slope of 2. Here's the y-intercept. Up 2 over 1. Wow, these are the same lines, really in different form. So I'm going to draw that. Well, they have actually infinite number of points in common. So when they have an infinite number of points in common, we just say there's an infinite number of solutions. So in summary, we know that we can have either one solution when the two lines cross. We can have no solutions when the two lines are parallel, or we can have an infinite number of solutions when the two lines are really the same line but in different forms. So that concludes this section.